Okay, what's up, everybody? Today we're going to be talking about free radical substitution, and I'm just going to kind of explain what free radical substitution is and what it's used for. So, first off, what is free radical substitution? Free radical substitution is a type of organic reaction where a hydrogen atom in a molecule is replaced by another atom or group. And most of the time, these atom or groups are going to be halides. And it does this through a mechanism involving free radicals. And what a free radical is a highly reactive atom or molecule that has an unpaired electron. And what is free radical substitution used for? For the most part, free radical substitution provides a way to replace a hydrogen atom with a halogen, like chlorine or bromine, and that introduces it to a more reactive functional group. And these more reactive functional groups make it easier to synthesize other things. And it helps everything out. So, once the halogen is on there and replaces the hydrogen, you can convert them into a wide range of other compounds. And some of these examples are alcohols, amines, or just more complex organic molecules. And it just helps you further synthesize things. And the reaction of free radical substitution is a three-step reaction that usually needs heat or light. And the first step is initiation. And in initiation, basically, you're going to form your radical. So, say we have Cl2 in there. In the Cl2, each chlorine group is going to split, and it's going to make a radical, which is going to initiate the reaction. And the second step is propagation. And in propagation, you're going to take that radical, and using that radical, it's going to make your products. And basically, it's just how the reaction is working in the middle and what is forming with what is forming with the radicals to make your products. And the last step is termination. And in termination, this is where it gets a little messy. Termination basically is whenever radicals, they don't react with what they need to, and instead of forming the major products, you're going to get a bunch of minor products. So radicals are going to form with each other, that like the identical radical to make, if you have two Cl radicals, it's just going to make Cl2 again. If you have two CH3 radicals, it's going to make two methyl groups like connected to each other. And as I was talking about termination, it gets a little messy. So there's a lot of downside of free radical substitution. And the main one is that it is not very selective and it's not controlled very well either. Since the radicals are extremely reactive, once the reaction starts, it's pretty hard to stop, and it tends to just keep going in multiple different directions that you don't need, because you're just looking for that one direction that gets you to your major product that you're trying to form. But for radical substitution, it kind of just goes wherever, and you're going to get that major product, but you're also going to get a lot of minor products, and that leads to multiple mixtures and messy mixtures that have your major product in it, but it's not just a single compound. It's also very hard to stop at one substitution once one hydrogen is replaced, because the new product is often still reactive, so it can keep reacting again and again, which again is just going to get messy and not form the single compound that you want. It's also got low selectivity, which just means if there are multiple types of hydrogen in a molecule, substitution can happen at any of those different hydrogens. And it's going to give you multiple isomers, and it's not going to give you the one thing you're looking for. And this right here is just, it's an example of free radical substitution. So CH4 reacts with CO2, and as I said, you're going to need heat or light. And this is going to form your two major products. And later in the video, you're going to see a whole walkthrough of the mechanism. This is kind of just a quick overview. As I said, the initiation step is just going to make your radicals. And if you come down here to the propagation step, it's your radicals reacting with everything to form your major products. And then, as I said, this termination step, it's the radicals reacting with identical radicals and just every other thing that's in this reaction. And this is where it gets a little messy and forms a lot of minor products.
All right, so the reaction that we have is free radical substitution, and in this reaction there is three steps. So I'm just going to start off with the reaction that we're using. And the first step is an initiation step. And in this step, this Cl2, it's going to split apart, and that's going to give us two Cl radicals, which is going to help us to start the reaction.
The second step is propagation. There's two steps of this. In the first step, we're going to have our CH4, and it's going to react with one of the chlorine radicals, and it's also going to create a CH3 radical while making hydrochloric acid. And then this radical, the CH3 radical, is going to react with the Cl2. Bond is going to break, and it's also going to attack this radical. It's going to create a product of CH3Cl. There will also be the Cl radical formed.
Also, while this whole reaction is happening, there's a third step called termination. And basically in the termination step, while these two products are being formed, there's a lot of other minor products being formed, and that can happen between any radicals. So, for instance, a Cl radical can react with another Cl radical, and that's going to end up forming just a bond between the two Cls. And you can also get a chlorine radical that reacts with a CH3 radical, which will give you a CH3, or you can get two CH3 radicals that react with each other and form that bond. So while all this other stuff is happening, there's also a bunch of minor products being formed, and that can be by any combination of these radicals.
Our sources for this video were the Williamson textbook and the video on free radical reactions by the Organic Chemistry Tutor on YouTube.